Good day, viewers. You are welcome. How to solve these nice radical equations? We have square root of k inside square root of k inside square root of k equals 81. I want to find k. Or you consider solution. So here from what we have square root of k multiplied by square root of k inside square root of k equals 81. And by considering this method, because I'm going to be presenting two methods to solve this. So here we have the first root here. We can separate this as the square root of k multiplied by. So for the second root, it is covered with the first root, as we are going to write this as square root of k multiplied by, while the last one here is covered with three roots, as we consider it as the square root of k equals 81. Then in the next step, we are going to apply the reverse of this root, that the root here is just like the power of 1 over 2. We can write this as k raised to power 1 over 2 multiplied by, and here also we have k raised to power, so for the first one here is the power of 1 over 2, then everything also raised to power of 1 over 2. So for the last one, we have k to the power of 1 over 2, and this raised to power 1 over 2, and also raised to power 1 over 2 equals 81. And if you consider the rule of exponent, if you have a raised to power of n raised to power m, it is equals a raised to power of n multiplied by m. That is, we have k raised to power 1 over 2 multiplied by k raised to power 1 over 2 multiplied by 1 over 2. That is 1 over 4 multiplied by k raised to power 1 over 2 multiplied by 1 over 2. That is 1 over 4. And 1 over 4 multiplied by 1 over 2. That gives us 1 over 8. And this equals 81. And in the next step, if we have a raised to power n multiplied by a raised to power m multiplied by a raised to power of p, this equals a raised to power n plus m plus p. As when we apply it to this, we have k raised to power 1 over 2 plus 1 over 4 plus 1 over 8 equals 81. And when we find the LCM of the power of k, we consider this as k to the power of, so the LCM here is 8, and 2 in 8, that is 4. 4 times 1, we have 4 plus 4 into 8, that is 2, and 2 times 1, we have 2 plus 8 in 8 is 1, 1 multiplied by 1, that is 1, and this equals 81. So from here, we have k equals 4 plus 2 plus 1, that is k raised to power of k raised to power 7 divided by 8 equals 81. And to get the value of k from here, what we are going to do is, by raising these two sides by power of 8, I raise this by power of 8, it shows that 8 cancelled 8, and when 8 cancelled 8, we have k to the power 7 equals 81 raised to power of 8. And from here, we have k power 7 equals 81. We can write it as 3 to the power of 4, that is 81, and all raised to power of 8. And from the rule I've applied above, that we are going to multiply 4 and 8 together, and here is k equals 3 to the power of 4 times 8, that gives us 32, and here is k to the power of 7. Then let's try to raise both sides by power of 1 over 7, and here is k to the power 7 raised to power of 1 over 7 equals 3 raised to power 32 and all raised to power 1 over 7. So if 7 cancels 7, we are going to get the value of k equals 3 raised to power 32 times 1. We have 32 divided by 7. And here is the result to this problem, as we are going to consider the second method to this. For second method, suppose we take the square of both sides. We have this as k multiplied by square root of k multiplied by square root of k equals 81 to the power of 2. So when we take the square of both sides, the first square root will cancel with this square. And again, we have this as k multiplied by square root of k multiplied by square root of k equals 3 raised to power 4 all raised to power of 2. And when we multiply 4 by 2, we are going to get 8. So here is k multiplied by square root of k inside square root of k equals 3 raised to power of 8. And in the next step, we are going to take another square of both sides, as we have this as k multiplied by square root of k multiplied by square root of k all raised to power 2 equals 3 raised to power 8 multiplied by 2. So here k we take squared, we have k squared multiplied by, so this root will cancel this, and we have multiplied by k multiplied by square root of k. So only this square root will remain, and this equals 3 raised to power 16. And again, when we multiply k raised to power 2 by k, we get k raised to power 3 multiplied by k equals 3 raised to power of 16. And when we take the square of both sides again, we are going to have this as all squared. So this raised to power 2 and this also raised to power 2, which is multiplication form. Here we have k raised to power 3 times 2, that is 6, multiplied by square root of k raised to power 2 equals 3 raised to power 16 times 2, that is 32. Then we have k raised to power 6 multiplied by this cancelled, as we have k equals 3 raised to power 32. And when we multiply this together by rule of indices, we have k raised to power 7 equals 3 raised to power 32. And let's take the 7th root of both sides. We have this as 7th root of k raised to power 7 equals 7th root of 3 raised to power 32. So this cancels this. Then we have k equals, so 7th root is the same thing as 3 raised to power 32 and all raised to power 1 over 7. So which we can conclude that the value of k here, when we multiply 32 by 1 over 7, so we get k equals 32 3 raised to power of 32 divided by 7. And here is the second solution to this as the second method. Thanks for watching, and don't forget to subscribe and share it. Thank you and God bless.